Well, hi, good morning. Thank you for joining me here on July 2nd, a day where the air is supposedly smoke-free here. I might get a couple of days of smoke-free air. So last night, just before I went to bed, I stepped outside and it smelled like somebody was burning wood down the street. Now, it's not very likely at 11 o'clock at night, but that's how much smoke there was last night. But today, the sky is blue, it's full of clouds. Okay, what am I going to do today with this radio? So yesterday I did the IF alignment. It would appear that I got some improvement in the operation of the radio. And so there's many more steps, or more steps anyway, to the alignment process. And we're just going to move towards the antenna, from the IF towards the antenna, which is basically this tube. Not that the tube itself is involved. And a whole whack of adjustments. And are they accessible on top here? Apparently not. They must be underneath. Yeah, there they are. Wow. Lots of adjustments. Typical of a, what is that on there? Yeah, okay. So I have read through the alignment instructions that I need to follow. There is something peculiar in this paragraph. Something I've never read before, but interestingly enough, about 4 or 5 radios ago, when I was doing the alignment process on the radio, it turned out that as I adjusted the RF adjustment, like these on this radio, the local oscillator started changing frequency. I've never experienced that before in a radio, and it kind of drove me nuts, because as you try to tune things over here, something's moving over there. When you try to move over here, they move over there. The whole thing became very difficult, and in fact I think I just kind of threw my hands up. My thinking was there was something unusual about the radio, the way some part or something, and I just didn't care to pursue it into its depths to find out what was going on with that radio. There's always another radio coming here in my shop, so to keep the train moving. And I was getting fairly good results anyway, the way I was doing it. With this radio, there's a warning of the same thing. That when you go to do the RF adjustments on the highest shortwave band, the local oscillator will probably be affected. And they have a workaround in this paragraph. So I'm going to put this up on the screen so we can all read it. I've read it I read it twice. I'd probably have to read it a couple more times just to be sure I'm following it properly. And it could be, in today's world, there's a lot more stuff around. Most importantly, my SDR radio, which enables me to see the local oscillator frequency. And so that might help out with this process. Unfortunately, in here, although they explain in detail how to do it, the Y part is missing. They don't quite explain what exactly is happening in the radio. But maybe with a little more thought, I can come up with a better approach than what they recommend here. Which you'll see is a chunk of effort here. Let me get it up on the screen, and we will read it. I think today, I got a bit of a late start here. Just getting through this part will be good enough. So if we look at the overall layout of their instructions here, this is for the intermediate frequency. This paragraph, we did that yesterday. And then we start on the radio frequency, circuits, all this. It's broken down into separate steps. First one, tuning range, 7 to 22 megacycles. Next one, tuning range 2.3 to 7.4, which they call the police band. I don't think there's any police down there anymore. And then the last one, probably the most important one, is tuning the AM broadcast band. There's quite a few steps involved in that. So if I can get through this, that'll be great. So let's just read through the first paragraph. Remove the signal generator output lead from the grid of 6A8. What was it doing there? It's because of this. So they're just thinking you were just following on. So you're removing it from there and connecting it through a 0.1 capacitor to terminal number 1 on aerial input panel. And that's 4 screws at the back that I'm just still not 100% sure of. rear chassis. Connect generator ground lead to chassis. Okay, that's clear. Terminals 2 and 3 of the aerial input panel must be connected with the connector link provided on the panel. Now, actually, I was thinking about this. Won't look at it right away, but we'll look at the actual panel in a moment. Okay, now here's the interesting part. Set the tuning range switch in position number 3, turn signal generator and receiver dial to 18 megahertz, and adjust the compensators 19 and 6. So one is the oscillator and the other one is for the antenna for maximum output. Here it comes. The adjustment of the antenna compensator on the high frequency range causes a slight detuning of the oscillator circuit. In order to overcome this detuning effect, connect a variable condenser of approximately 350 picofarads having a good vernier drive across the oscillator section of the tuning condenser. So add another tuning capacitor. 350 picofarad is typical of a tuning capacitor. Most of them are go from 2 or 3 picofarads up to around 350. So now I've got some. Good vernier drive? No. Leaving the signal generator and receiver dials at 18 megacycles. Tune the added condenser so that the second harmonic of the receiver oscillator will beat against the signal from the signal generator. This is a particular model of signal generator. They're trying to sell this to you. The 088 signal generator. The antenna compensator 6 should now be adjusted to give maximum output. So what's going on? Leaving the signal generator and receiver dials at 18. Tune the added condenser so the second harmonic of the receiver oscillator will beat against the signal generator, the signal from the signal generator. It's not quite adding up in my head. The antenna compensator number 6 should be adjusted then to give maximum output. Now remove the external condenser and turn the compensator 19 to maximum capacity. Then, without moving the signal generator or receiver tuning condenser, back off the compensator, turn it counterclockwise, until a second peak is reached on the output meter. The first peak is caused by tuning to the image signal and must be neglected. Okay, let's read that key line again. Leaving the signal, connect the capacitor across the oscillator section of the tuning condenser. So you have another tuning condenser connected across it. Leaving the signal generator and receiver dials at 18. Tune the added condenser so that the second harmonic of the receiver oscillator will beat against the signal from the generator. So they're both tuned to 18 megahertz. You tune the radio to 18 megahertz. The local oscillator of the receiver is either 455 above or below, which we could figure out if I studied this part down here a little more, but it's either above or below. It's not 18. So it would be like 18.5. We can use that number. Let's pretend it's the local oscillator is at 18.5. Tune the added condenser so the second harmonic of the receiver oscillator. So the second the harmonic would be the second harmonic. Wouldn't it be the first harmonic? Second harmonic. I don't give you what the frequency would likely be. So I think they mean double the local oscillator frequency of 18.5 would be 37 megahertz. Tune the added condenser So the second harmonic of the receiver oscillator will beat against the signal. What signal? The 18? Or do they mean 36, the second harmonic of the oscillator, of the generator? I better use the words right here, the generator. Because the generator's second harmonic will be 36. So let's say you've done that. Now you've added extra capacitance and you've managed to get some beating occurring. Beating is where the two signals are the same frequency. If they're slightly divergent, the difference frequency can be heard. How would you know this? It says do it until it beats. Well, how do you know it's beating? Yeah, listening to the speaker on the radio? I have a lot of questions about this. The second harmonic. Now, because I have an SDR here and we can use the spectrum chart of the SDR, we can see all this stuff. So if I actually go to do this method, we should be able to see it. Second harmonic of the receiver oscillator beat against the signal. I don't get it. I don't get it. Okay, then so once you've managed to do that, you're tuning the radio now with an additional capacitor. You're pushing the local oscillator around with an additional capacitor. And why? Because when you go to adjust the antenna, the oscillator will move. So now the adjuster gives maximum output. Now remove the external condenser, turn, and then you go to compensator number 19. You tighten it down and you loosen it up and skip the first signal you receive because it's just the image. It's on the right, it's on the wrong side of the main signal. I'm not getting this 100%. I don't even see what they're really saying here, how you would actually do this. How are you going to do this? How are you going to do this? So either I'm misreading this or it's just not, somehow it's being translated on the way into my head and I've got a wrong impression of what they're saying here, or what they're saying here just doesn't sound terribly doable. And again, where it's not 1937 here, I have a software-defined radio. Boy, wouldn't that blow their heads right off if they saw what I've got here. There's got to be a better way of doing this. Let me go on to the rest of them here. They're all kind of straightforward, similar to any other radio. Just this thing is crazy. It's crazy, I tell you. Well, I'm feeling so crazy now. I think I need to drink coffee because coffee is anti-crazy. I'm going to go do that. Okay, I think we're kind of ready to go here. This will be picking up signals from the radio and they'll be displayed on the SDR just up above here, and I'm just going to put that right there for now. And yes, the antenna, a couple things here. The antenna. So what I noticed, but I hadn't really thought much about it, got a extraneous screw here. I wonder what happened to the original one. This little piece here, this shorting bar, can fit here or there. And I noticed the cutout here, so I realized there was some intention for it to go the other way. And this is normally what you would do. Like a lot of these radios are like this. They have two inputs in case you have a loop antenna which has two wires coming from it. So you would leave them both like this and hook up to it. And this guy, I guess on this radio you would swing it over there. If you just have a single wire antenna, which you would use for short wave, then you would want this over here, grounding one side of the balanced input. Basically that's, you're switching from balanced input to an imbalanced input. In case you're a ham radio guy, you'll know what I'm talking about. Probably better than me, in fact. Okay, just tighten this guy up a little bit. We're going to feed the signal into terminal number 1. And here it is. Turn it down. Okay, and we're going to want to, they said, feed it in here. And the other lead onto the chassis. So I will do what they say. Where can we clip this? Nice place to clip it. Way down here. Out of the way. Okay. Let's get this out of the way. I need to tune the signal generator to 18 megahertz. Not 14, 18. Now is 18 the top or is 18 the middle of that band? Let's take a look here in a moment. 18. Okay, that's going to do. Now, by the way, this is the first time through the alignment, including what I did yesterday. I fully intend to do the whole thing again. I have found that doing this work is iterative. Some of the instructions are iterative in themselves, but the bigger picture is the whole thing needs to be done a couple or 3 times, for me anyway. Now we want to hook up the voltmeter, which I just took out a view of the camera, and we want to hook it up to a good spot. And the good spot is normally the input side of the volume control, but not always. Sometimes there's a capacitor blocking DC from the volume control, from getting to the volume control. Volume control's here. There's 3 terminals on it. 3 terminals. The middle one is the sound output terminal. We don't want that one. One of them is usually grounded, and the other one is the input. I can't operate my fingers that well. So I got to figure out which one of these. Is this one or this one? That's the input. And in this case, neither of them are clearly grounded. One of them has a long wire going on it. So we'll do it by using the meter and detecting which side has some DC on it. You may have to move up ahead of some capacitors like this one or this one to get that DC, but that's fine. We'll figure that out in a moment. The radio has to be operating for me to do that. But I am ready here. I have a clip lead ready to go. Now tuning the radio to 18. Okay, so we need it on the correct band, which I think it must be there now. And 18 on the dial. So this is 7.5. The 18's right at the top of the other end of the dial. Not at the top. Not at the top, right in here. So that's going to be about 18 there. When a shortwave radio covers a large range of frequencies, like this one goes from 7.5 all the way up to 22, it almost guarantees the tuning is very, very sensitive. A little bit of movement in the tuning is a big deal on the dial. So that's what makes radio like this less attractive for listening to shortwave. And in my own experience with this radio so far is when I was tuning towards a sorry about that. We're tuning towards a particular frequency or station. I went right by it a couple of times. Didn't hear a thing. Well, when I finally slowed down enough, I got it. So you can easily zoom past stuff with a radio like this, and especially obviously weaker things. Okay, so we're at 18. We're at 18. We're ready on the AVC measurement. Oddly enough, these instructions say nothing anywhere about where to hook up an indicating meter. I was really quite surprised. You know, maybe it's hidden up in here somewhere. I read through this again. It should really be saying it right in the opening line, but it does not. It does not. So I have chosen to use the AVC voltage. Now, often that's not recommended. There's a couple of reasons for that. And the big one, I believe, is because back in the day, a lot of guys had crap meters. And those crappy meters, if they tried to hook it up to the AVC, would upset the radio too much. I don't have crappy meters. I have vacuum tube voltmeters. And of course, any meter today is such high input impedance, any common meter, like this kind of thing. Very high input impedance can be used. I don't like the digital readout for a value that's going up and down. I have too much thinking involved. I like a pointer. I like a indicating meter here. Okay, and this is set to positive 500 volts, but really we're going to be looking for a negative voltage, a small one. So I'll set it to 50 to start with. 50 negative. So a negative voltage will cause the meter to swing upscale. Now the next step here is going to be turn on the radio and figure out where I can get the AVC voltage from. Okay, so let's turn on the radio. Okay, give it full power, which today is 113 volts. Going to go down a bit as the radio draws a bit more current. This will drop a wee bit. 112, that's fine. Now, I wasn't looking. Did something show up on the SDR? The radio tuned to 18. The local oscillator should be 470 kilohertz away on one side or the other. So 18.5 or 17.5, we should see something. And I don't see 18.5, 17. I don't see a thing. Now, it could be the radio's not really tuned to 18. It could be the alignment is so far off. Let's turn this. See if anything moves on the SDR. My SDR may not be in a... Ooh, this is hard to turn. Not be in a position to... this is 18. There, that's 18 on the dial. I don't see a thing. Maybe it's on another band? No, that's broadcast. Ooh, I got the volume right up. That's broadcast. That's the police. The police. Let me tell you something about the police. When my wife and I first met and we were going to college together, we were going to go downtown Toronto. I can't remember why. Go to a store, go to a restaurant, I can't remember. We were students, probably not a restaurant. We came out of the apartment building we lived in. It's actually a student housing co-op called Neil Wysick. We came out of it and headed towards Yonge Street in Toronto, which is just a couple blocks away. We were walking along and we passed this coffee shop that was called Edgerton's. It's named after Edgerton Ryerson, and Ryerson was the guy who devised the original school system in Ontario. Edgerton's. And it was just a little, like a coffee shop. It was a short order kitchen, and oddly enough, they often had music. They had live music, which I don't exactly know how they managed to afford to do that. So sometimes as you walk by, you'd hear some music coming out of there. And this, I'm going to guess now, I can't remember. It was probably 1 or 2 in the afternoon. I can't remember. And as we walked by, I could hear some music coming out. And I said to my wife, listen to that. That sounds great. Why don't we go in for a coffee? And we stopped for a moment. But then we felt we didn't have enough time to go in for a coffee. And we kept going. If we'd gone in and sat down, we would have watched the band, The Police, playing their first gig in North America in this little coffee shop. And we would have been sitting a couple of feet from the band because it's so small. Okay? It couldn't hold 20 customers. And we walked by. And the interesting thing is, I stopped and said, listen to that. That sounds great. Now, I'm not a music aficionado any more than anybody, but that caught my attention. Oh my gosh. Missed opportunity. I've regretted that right to this day. So, but can't go back and change it. Okay, that's my police story. Okay, now. Yeah, you know that old thing, right? If I only knew then what I know now, wow, would my life be much better. Fortunately, that's not how life works. Okay, what are we going to do here? No local oscillator showing up. Why is that? Why would that be? Why would that be? Because my pickup coil's not in the right location. So it's going to be up around these coils here. don't see anything showing up. And we are tuned to 18 on the dial. Okay, so I'm see, can I hang this in here or just kind of stick it in here? So one of these are oscillator, and one of them is the. I'm going to guess this is the oscillator over here. So I'm going to stick this over here like this. Try not to drop it in the radio. Okay, let's go hunting here. I'm going to tune the radio in hopes of finding a local oscillator showing up as a strong signal. There's nothing happening. There's nothing coming out. Wait a minute. Oh boy. Back to 18. Well, we're off to a bad start here. Yes, a very bad start. It's impossible. Even if these are the oscillator coils, this thing's going to pick it up from that distance. Let's try another band. That's all I can suggest. So we'll go to the police band. All of a sudden, police music starts playing out of the radio. That would finish me off. So we're tuned to around 6 megahertz. So we'll change the SDR now to also be around 6. So here we are, around 6 this way. Where are you, Mr. Oscillator? What's happening here? Have I done something really dumb? It's always possible. No, I verified this by pinching it. Okay. But I've picked up shortwave on this radio at 9.3. I couldn't do that without a local oscillator. We're off to a really good start here. So once again, around 6. Where are you? I drank coffee. I don't understand. Okay, we're going down to AM here. Now we're around 1400. Okay, I'll take the SDR down there. 1400. Okay, so lots of noise, as you can see. I'd say that's it right there, I would say. Now we will tune the radio a bit and see if it moves around. It does not. Oh my! What just happened? Oh my gosh. Well, for some reason the local oscillator was not operating, and then suddenly it was. What could it be? What could it be? So turning this thing's pretty rugged on this radio. I could have stressed almost any part of it. I still have a tube sticking out of a tube extender, but it's not the oscillator tube. This is the oscillator tube here. I do not have the covers on 2 of the tubes. I only have half the covers, half the shields, but I don't think that would make that much difference. Certainly I have to have the shields on to finish the alignment, but I also need the bottom plate put on to finish the alignment. And just to show you, the bottom plate comes with a series of holes so you can access these. Put the bottom plate on. That's part of the last things to do. My experience with those bottom plates is they don't make a lot of difference either. What happened here? Need a switch? Tuning the radio? That gotta be something else. What was it? Well, you know, like if it's not if it's not going to reoccur, we can't do much about it. But it looks like it was probably interrupting, whatever happened was interrupting the oscillator in all cases. Not just one band or two. Oh, that's not very good. That's really not very reassuring. Well, let's work our way back up. So we'll go to the police band. And we'll look around 5.5 megacycles. So we'll look on here. 5.5. That's probably it right there. We will tune. But it's not going anywhere. Oh my gosh. So now I'm tuning the radio and I'm listening, even though I've got a signal generator connected, to hear if I have any notion that it's scanning frequencies. Doesn't seem to be. I think the oscillator went away again. Is it this switch? I apologize for that, and I blew my ears right off there doing that. Luckily you've got some limitations there through the YouTube system. Definitely an oscillator there. In fact, you can see a harmonic is showing up at 5.7. If we tune, that harmonic should move. Yeah. Okay. We go back. You hear all the hissing and stuff it's receiving. Should sound pretty much the same here. But it sure doesn't. We have another problem. We have a problem. I'm not quite expecting that. So how did I manage to pick up 9.33 megahertz the other day? The oscillator must have been working at that time. Oscillators are not easy things to work on when they misbehave. What could it be? What? Could be all kinds of stuff. There's a lot of things it can't be because it works on one band, and it apparently did work on other bands. It's just not working today. Oh my gosh, I'm totally stomped here. Stomped, yeah, I've been stomped. Stomped. That's it. Stomping and stopping together. Well, okay, now the volume up. If the oscillator comes on, I'm sure the sound coming out of the speaker will increase. This is where the oscillator tube is. Anybody loose in here? Doesn't seem to be the case. How come the oscillator was gone on all three bands, then suddenly it was back on the broadcast band, but doesn't appear to be back on the other bands? That's really screaming at the switch. Can you hear it? Screaming at the switch. I hear it. Okay. Come closer. And look upon this radio. These look like the factory work. This one back here, something has gone on with this coil. There's a wire here. There's a wire sticking out here. This is quite, reminds me of the last radio I worked on. There's a wire here. A wire sticking out here. A wire sticking out here. Oh, that's a lot of wires sticking out. There's some kind of white paintish stuff here. This looks resoldered. These all look resoldered down here. Somebody's gone after this coil. There may even be a solder spot right here where perhaps a repair was made. Why the white paint? Or is that really a problem? Now, almost certainly each band has its own coil. This would be the broadcast coil, I think, the one that's got the most wire on it. It's operating at the lowest frequencies, needs the most inductive impedance here. More coil. This would be the middle, this would be the police band, and this would be the short wave. That's how I would interpret these. Well, you know, it's a shot at a bit of a long shot, just cleaning the switch. What would that do? Does that mean somebody's pulled this whole unit out to work on it? So these wires appear to be resoldered. There's an awful lot of wire, like all these wires would have to be disconnected and reconnected if you take this central unit out. Lots of capacitors replaced here and there. Still no local oscillator. I may not get any farther than this today, by the way. I may not get anywhere. Why did it work? Let's just... Ooh, what's that action? Where'd that come from? Lots of goodness in the AM band. No goodness here. Look at this whole piece moves. Hey, look at this. Oh boy. I'm gonna find a bad connection. You know, things moving like that could eventually lead to a wire breakage or something like that. Or more typically, in one position things work, and when you move this, and this thing moves. So I've seldom had a situation. Ooh. Is that for me poking around up here? I didn't attach my meter yet. I didn't even get that far. Hey, where'd it go? Where'd the hum go? It just kind of dropped out. Oh, this is where I was soldering yesterday. Something more going on up in here. Stop now. Oh. Something's going on. Not that it has to do with the local oscillator, or does it? Ooh. Oh. No. So there's a wire right here. Which runs around the back here. There's lots of things connected to this terminal. This terminal is probably a ground. Oh, you know what? It is a ground. I can see it. This is a ground terminal. There's a wire coming from it, and that wire is connecting to this terminal here. This would be the grounding terminal of the. There. That's all you need. You need a stick. Now that the stick's in there, she's perfect. Turn the light on. Which end? So I believe what's happening is the volume control is losing its ground connection. And that turns it into more of an antenna, but it's hooked up to an audio amplifier, so it's not going to receive radio stuff, but it will receive hums, clicks, noises, buzzes, other audio type stuff, and I think that's exactly what's happening here. Could be I just need to solder that one. It's nothing to do with the problem we were originally on to. Okay, we're going to solder it. There goes my air conditioner. Yeah, it's a nice day outside. It was actually quite nice yesterday too. Guess this has just about as much chance of making it worse as making it better. Okay, I don't know if that did anything. This is why you want to work on radios one step at a time. Because you take 2 or 3 steps, and in the middle of taking it, you bump this wire over here. You never know there's a problem coming from here. You've done 3 things. You're going to think it's the 3 things you did. You want something totally else. Something totally else. English is breaking down. Well, I don't hear any hum. Seem to get it. Huh. Well, yesterday I thought it was this connection. And maybe it was. But today it was this one. But I don't think it's going to help the local oscillator situation. Is it? We're on broadcast band. Let's go back to shortwave here. Shortwave. tune it a little bit. Yeah. That's me saying, geez, I don't know what to do here. Offhand. Oscillators. Bad news. Could it be so simple? I don't have the shield on. If I put the shield on, it's going to oscillate. That's a stretch. Yeah, you see, I haven't cleaned the band switch yet because I'm really not thinking it can be the band switch because there's just nothing. Like usually, if the band switch is dirty, you're going to hear, stuff's going to happen. Am I just completely wacko? Ooh, that's possible. Let's just put an antenna on here. Wait a minute. Why use an antenna? I got a signal generator ready to go, and I know. Okay, I know I'm tuned to around. Trouble reading that. Come on, flashlight. Frustration is rising. I can feel it. We're at 17 megahertz or so. So I will pump in 17 megahertz here. Let's see what we get. Pump is the word. That's a strong signal now. Pretty fast. Not the thing. No, this is pretty darn convincing. There's no local oscillator in this radio anymore. It's gone away. It's left us. Now, I did operate the radio successfully on shortwave. Picked up a station with the shield half off. So that really can't be the shield. It just doesn't make sense. That might shift the local oscillator a bit, but I don't think it would even do that. Oh my gosh. We've gone distinctly downhill here today. I don't think I did anything. Did I do something? What did I do? Did I do something I don't realize? Am I just going to get myself in bigger and bigger trouble? Because I don't realize the silly thing that's going on? I don't think so. Let's lay the radio down. Maybe it's upset because it's tipped up. Yeah, it's just, it doesn't like it. So yeah, you're going to tip me up? I'm not going to work. There's a fat chance on that. But this is how I'm reaching levels of desperation here. As I say, if you don't know what to do, just do something anyway, because maybe you'll bump into stuff. Let's see if now, did we just bump into something here? We turn it back on. Now, if the radio starts working, I would really be upset. So this is the mixer tube. It's certainly hooked up to the speaker. Oh! My oscillator started. Right where my cursor is. Now hold on a minute. Hold on a minute. How could that start the oscillator? So, just so you know, she's gonna blow. See the oscillator frequencies jumping around. The component that's breaking down right in front of us. Well, this'll never do. try tuning the radio just to make sure that is an oscillator there. Oh, I'm right past the station. It's my signal generator we're hearing. Where'd my stick go? What I'm doing here is I'm wedging this thing. When I put the radio on its side, this thing's going to tend to hang this way a little bit. It's mounted on rubber grommets. I'm not exactly sure why yet. Perhaps it's accidentally grounding to the chassis when it shouldn't. A little stronger than that. Oh, I'm grounding it with this if I use that. Let's use the other end of the stick. Okay, that time the stick was right inside this hole here, and I bumped something. Oh my gosh, this is so sensitive. Okay, there's a wire I can see down in there. Okay, down in there. Something to do with this. So the swooshing and retuning is just me flexing this a little bit, and that's not what we're after. We're after a big dramatic thing. Wire here. What did I hit? I shoved this in way down. Oh, way down under here. Way down under here. Okay, I'm going to do that. I'm going to shut off the radio. Stick the stick in. Tip the radio up and look for the stick. And the stick fell out. Well, I can see clearly. I can see clearly now. The smoke is gone. The stick was coming in. Let me just pull this forward here. The stick was coming in right in this area here. We need more light on the topic. Coming in right this area here. Let me stick the stick in. I stuck the stick. Well, it would have come all the way over, hit this wire, hit this terminal. There's a capacitor that somebody installed way down in here. How did they do that? That must have been quite a challenge. Okay, we need the radio on again. Switching on. You would kind of expect if you've got a totally dead oscillator, you've got an open circuit or a short circuit somewhere. But that's not necessarily the case. The conditions have to be right for the oscillator to oscillate. And if you just move the conditions far enough away, the oscillator will stop oscillating, but nothing's really broken. No broken wires to find. Okay, we're back in business. Let's say the radio's not working at this point. Just poking around in here. It's very, very sensitive. Nothing is happening. Where's that capacitor I spotted? Nothing is happening. Oh, stick the stick back in. really do need a stick in this radio. I hit this terminal here, I think. This wire. That terminal. Just a switch making bad contact, and I'm flexing the switch. Let's give it the cleanup. Okay, now use this stuff to catch fire. You may be laughing, but I have actually set a radio on fire, doing the kinds of things I'm about to do to this one. I had a fire in a radio a long time ago, but because the fluid I'm going to put in here, extremely flammable aerosol. Great. Looking for some excitement? Oh, let me look at that switch just a little bit closer. Where are the contacts? Bear with me a moment here. Okay. Take a look at the switch. Can we see it? The radio's on, so I gotta be a little careful here. We've got focus issues. I can come in this way. Pretty dirty. It looks like a corroded contact plate. I'm just rocking the radio back and forth, and something is being flexed enough to... Let me just switch cameras again. Investigate that. Just this connection. I put this on a screw. These screws are terrible if you don't tighten them right down. Let's eliminate that possibility. Put it right on the terminal back here. There we go. Okay. Chasing them down one by one. I think that there's switch contacts on both sides. Yes, there is. Switch contacts on both sides. Let's just power this off while I do this. And I need to... Can't see what's coming out of this when you use it. How about the other switch? I bought it with that. May as well. This product claims to clean corrosion. De-oxit. It's just a wee bit hard to believe that there's something that can do that. That you would be willing to spray on stuff. Flushing action, that's probably the main thing. Removes oxidation, improves connections, seals and protects surfaces. Oh, how can they make that claim? Because there's a little bit of oil? Get a cleaner audio, cleaner video, and reliable data. All in the can. Fantastic stuff, it's all over my fingers here. Okay, now we give the radio a try. We're starting on broadcast. Maybe it's too loud. I'll put it here. We'll start on this band. We'll start on that band. This is not at all as often as the case. I didn't think I'd be doing this today. But it's one of the great things about doing alignment work is you're working the radio, you're listening to the radio, and if there's more problems, you're liable to find them while you're doing the alignment work. And if you're going to fix a radio like this and then I'm all done, now I'm going to align it once and be done, probably not. You probably have to go over it a couple times. So first time through, I wouldn't try to get it exactly correct. I'd try to get it good enough, and so speed up the process on that. Second time through, you go for precision. That didn't sound very good. Yeah, I got the volume up full. I flipped it on broadcast, and we didn't hear a thing. Yeah, it should have blown our ears off. There's that stupid hum is back. Come on, radio. That's a stupid hum. Oh, broadcast. Oh my gosh. We've lost it. We've lost it all. Okay, this might be loud. If I can make it work again. Shouldn't clean them. Let me go up here. No oscillator appears. It's quite obvious. There's no oscillator again, even on the broadcast band. Now you've done it. Now stick it in that hole. The magic hole. It's lost its magic. And you've removed the magic from the radio. And now have stable non-operation. Great. How could spraying some fluid on there do this? Shouldn't it just get better? I'm listening for any click, pop, noise, any response at all. Any response. Even applause would be welcome at this point, but I don't think I'm going to hear that. And we're coming up on the end of my time here today. Well, Jim, you've totally killed it. You've killed it dead. What am I not doing? I have full power. Got the antenna connected to the signal generator, shouldn't matter. Get the radio up on its side again. Oh! Ooh! I just turned the power off, and there was a sudden rush of pleasure came out of this radio. Who's to say for sure what all that was? Broadcast band. Volume's back. Okay, let's go police band, local oscillator. Any local oscillator. I'm looking at the SDR there. And that would be a no. Where are we tuned? We are now tuned to 5.5 megacycles. So yeah, we should see the local oscillator on the screen, but I don't. I don't see it. Okay, we'll go into the... I should have settled for the stick. You just tape it in and leave it. The magic is really gone. Really. So doing something to the switch appears to have affected this, so I think we can really focus on that switch. I think that's what's going to have to happen tomorrow. We're going to have to really examine it and look for something out of sorts with it, because the poking is not working. Okay, I think the radio needed a flagpole anyway. We're going to cut the power. I'm going to say farewell for today. And tomorrow we'll just focus on that switch and all the aspects of it. It really does look like somebody lifted this out of the radio at some point, based on this wild screw arrangement here. They probably pulled it out and lost the original screw. I never do that. I never have extra parts laying on my bench when I'm all done. And I'm not collecting endless screws from people's radios. No, I'm not. Okay, that's it. Thanks a lot for watching. Sorry this didn't really get anywhere fun, but or anywhere progressive in the repair of this radio. Actually, it's been a regressive day. But that's how it goes. See you on the next video.